All right, so not a whole lot of notes today. We're just on the second part of partial fraction decomposition as a means of integrating. It's not a real big hitter, but when it does the trick, it's the only thing that does the trick usually. So, kind of nice if you didn't watch the notes yesterday, distance learners and anyone in this room, the A group had to because they were with me. You'll need to watch these. That's the majority of the notes, and I'm not going to finish these because it'll take up your homework time, and I think we thought the worksheet went pretty well. Like once you got started, you got the process down. So when that happens, at least yesterday with the A group, they had 15 minutes to work and they got to number 8 out of 10. Like they were cruising on it. So you guys are good too? All right, so we're just going to set up until it goes. We'll decompose and then we'll just kind of dot it. If you don't know what to do after the dot, you have to go watch these first. All right? As far as turning in work, out there right now is worksheet number 4. I've let it sit because some people had to test, so no one's turned that in yet. But like you guys were all testing that day, so you didn't have any work time. We didn't do group work number 5. Instead, we did delta math. Okay. Worksheet number 6 is out there from yesterday. You'll finish it today. So the next thing you turn in is going to be a Google form where you turn in number 4, number 6, and distance learners number 3. You guys turned it in person already. All right, does that make sense? So there'll be a Google form and it'll say, if you haven't yet, turn in number 3, and then turn in 4, turn in 6. Some of you can do that today at the end of the hour if you already did 1 through 10. How many of you are done with 1 through 10? Pretty much everybody. Great. So we're going to finish it up with 11 through 17. They just get a little weird. Before we do that, though, I'm going to page through here because there's a problem in here I want to talk about. That's all our by part stuff. Okay, here it is right here. It's hard when we're doing one thing at a time. Like yesterday's entire worksheet was on partial fraction decomposition. You don't have this in your packet. The day before's, the 3 days before was all on integration by parts. And so you kind of get in a zone that's how you're going to approach the problem. In this chapter, the techniques themselves are not that difficult. You know, like by parts wasn't that bad, except worksheet number 4, but you won't have them that bad. And integration by partial fractions isn't that bad. It's just basically algebra on steroids, right? The problem is when they're on a test and they're all mixed together and it doesn't say at the top of the worksheet integrate by parts. That's what's hard with this chapter, is knowing which method to use. So I want to, and also we have had the inverse trig ones as well, right? So this chapter we've done the integration that results in inverse trig. We've done by parts, and we've done partial fraction decomp, and pretty much every day all the groups A or B have said, yeah, it's not that hard, right? But when they're all mixed, I want to show you your approach because we have another method or two coming. When I look at this one, my first go-to is always U sub, right? And I toss it out right away, right? I do. But then I say, well, is it by parts worthy? And I'd say no. Those aren't incompatible functions. The root isn't going to lead me to an x to the 5th. I'm not going to be able to by parts it. It definitely doesn't look like an inverse trig option, right? What am I looking for to pass off to arctan or arcsine? Those perfect squares, yeah. It's not looking good for that, and it really doesn't look like partial fraction decomposition because it's not even a fraction. So I've run through in my head all the techniques I've given you, correct? When none of them work, it always goes back to which one? U sub. U sub's the hammer. So when no other tool works, 9 out of 10 times, it can be U sub. It just might need to be played with. So watch. You would still follow U sub. I would have thrown it out originally too. Like even as a teacher, me making a key, I would have tossed out U sub. But I would have cycled back to it because nothing else would work. Does that make sense, Carl? So I'm going to say, because I had to have taught you a way to do it. So there's only a finite number of things to try. So I'm going to see if you guys can, just watch, don't write it down. So I'm going to say, well, I'm going to call that root U. You all right with that? Well, then my du is 3x squared dx. Raise your hand when you see what, that's good.
No, can you not do a tabular?
No, this isn't a by parts. They're not incompatible functions. It's algebraic fighting algebraic. Not algebraic fighting something else, but I love the question, so thank you. So right now I'm like, I want you to stare at it. Pop up a hand when you know how I could possibly do this. I got one, I got another little hand. Just wave at me, I got another one. Remember, it all has to go in terms of u. I've got the root down. I've got an x squared dx taken care of. I could replace that with 1/3 du. All right, I'm going to pick on a hand. Gabe, what would you do? Yes, I'm going to write it as x cubed times x squared on that side, just so you can see it a little better. Now I just saw somebody load my ear, you just all right, so that x squared dx at the end is my 1/3 du. How about the x cubed? It's all that's left. It's all got to go to u. What's x cubed? Go ahead, keep it going. Yes. It's u minus 1. Will a College Board do that to you? No. Will I? Probably not. Maybe if it's a bonus on a test. If you were at the U of M with a pretty rigorous professor, most definitely. Okay, so I always want to prepare you for all things. I'm not going to have you practice 10 of those, right? Now that would pass off to something you know how to do, right? What would you do in the integrand? Distribute, power rule, back sub. So keep in mind that although we're working in a vacuum on each day, like we are in partial decomp, so your whole worksheet is partial decomp, keep in mind u sub is still king. So having said that, let's go talk about, not that, oh, I'll do that tomorrow maybe. Not that either. I've got extra notes in here. Not that. I wanted to show you how it appears on the AP test. All right, is this where your next set of notes is? Perfect. All right, so first of all, this is set up for an obscure one. Long division is something we sometimes try when the degree of the numerator is greater than or equal to that in the denominator. This isn't right away partial decomp, because even though this decomposes down here into x minus, or factors I should say, do you remember what I said in the notes? The degree on the top has to be less than, right? So this wouldn't go to it right now, and I would try a long division. If it doesn't work, I try something. That's what's frustrating with integration. If there's a quotient and you're doing a derivative, you know to do quotient rule, correct? Integration is 10 times harder than derivation because you just kind of have to play. So we're going to go up here and review long division. We go x cubed, we divide it by x squared, and we get an x. Put it over its like term on top of that dividend, is that what it's called? Anyway, the next thing I do is multiply back in. We did this last year, so probably, but it's good to repeat. And I don't have very many examples. So I have x cubed minus 6x squared plus 5x, right guys? What do I do to the two levels then, Toby? The two levels? Subtract them, yep. Which means I'm going to be adding 6x squared, so I have a negative 3x squared, and I have a plus 19x and a minus 17. And until you get a degree less than, you keep on going. So I have a squared, and it started with a squared, so I can keep going. I'm not done. So now I divide this by x squared, and I get a minus 3. You should always get the exact same thing, because when you subtract, you want it gone, so keep that in mind. So I've now got x minus 3, and what would I have? Plus 18x, and a minus 15. Again, whoa, what the? Whoa! Sorry about that, that was weird. All right, now when I subtract, I'll get an x, and negative 17 minus negative 15 is minus 2. Now I have a degree less than what I started with. So watch when I rewrite it. It's x minus 3 plus x minus 2 over x squared minus 6x plus 5. So really what I'm integrating is x, which is easy, a negative 3, which you better know the antiderivative of, right? Plus the x minus 2 over a product of non-repeating linear factors. And this is where I said I'm not going to finish. If you didn't watch the notes, I'm just going to say, well, we know that's x squared over 2 minus 3x plus, and I'm going to go dot, dot, dot. Are you okay with that, Lodemeyer? Because it's a long process, and if you took the notes, you put in your time yesterday. So dot, dot, dot to finish it off. But what did this always pass off to yesterday? Always ended up going to what? Natural log, yeah. So I'm not going to finish them today. I purposely, I don't like to kill you with notes. Be careful of trying it when it's not necessary. Stare at this. It's set up where you might immediately go, this is decomp, because the bottom is x plus 4 times x minus 1. It very well may work, because the degree on the top is less than the degree on the bottom. You might be very successful, but I bet someone can do it in their head. So you have you stare at it. Raise your hand if you know that. Maybe without writing anything down. Tyler, you got it? Go ahead.
Natural log of absolute value x cubed plus 3x.
And he just said, and there's a 1/3 fraction correction. Now, what if somebody at home's going, what? Right? Or in here. So I'm going to show you that, but notice if you go to the right method. So even though this is set up for decomp, would I use decomp? No, that's a time sucker upper, right? But really what he's doing is he's going again. I always said in yesterday in the notes, I said you need to always keep your eye on U sub. Those of you who move on to Calc 3 and Calc 4, you will continue to use U sub, and decomposition might be one that pops up once, twice a year. Okay, so U sub is king. You should be really familiar with watching out for it. You should start to do it quick in your head like Tyler did, but if you're not doing it successfully that way, I would be careful. Come on! Sorry if I yelled in your ear, guys at home. Has that ever happened when I yelled? Like, oh. No? So this is 3 times x squared plus 1 dx. So then we have our 1/3 du, right? So all of this in the integrand is the u on the bottom, all of that, 1/3 du, which is why Tyler just immediately passed it off to natural log. All right, not going to finish it. Last up. It's kind of nice, right? Not on AP. Not my test. Today is just like the day where because I have the time in here, sometimes I do just a little bit more rigorous stuff to stretch. Like I like it when I ask things and only 3 hands come up, because if every hand came up, I'd be like, well, I'm wasting their time, right? This is one of those days. So this one tells me what to use as the substitution, all right? It says use the substitution u equals the square root of x plus 1. So let's start. Boom. Right? That whole thing, you. You good? Now what? Mm-hmm. Yeah. So she's saying it's that special kind from last year. Why is that helpful? Right. U squared minus 1, or x equals u squared minus 1. Good so far? What do you think? Gus, you good? So x is, I like crossing it off in there in the original, especially when they get complicated. Dx is missing. What's dx? What do you think? Well, yeah, dx with respect to u is 2u. So what's dx? 2u du. 2, right? U du. It's the weird one that got weirder, right? But keep in mind just the process that when we pass off to u sub, it's all got to go u, and it must be possible or I won't give it to you. So what did Lucy do? She played around with it, right? So now up here, gone, gone, boom. I now have non-repeating linear factors on the bottom. You guys go do that one. Get me the A and the B, and then we'll finish it off. So I want you guys to go ahead and use yesterday's stuff to say, well, this is actually something over u minus 1. I really don't want to do it because I want to make sure people at home who have not watched yesterday's, that's the guts of this. Today's is extra in terms of, it's one of those days where I say if you're kind of tied to the key, I'm okay with that today. All right? But I do like to expose everybody. So you guys go find the A and the B. I'll steal them from you if I get an agreement. If you're not doing it, did you not watch the notes? See? It's all like, what? And I'm not going to show you.
I don't.
LaRue don't play that, right, Jordan? He didn't watch the notes. I said, I'm not gonna, I'm purposely not putting it up here because I think I've got 3 who aren't watching them consistently. And I'm like, I'm not spoon feeding you 3. He lied.
Oh my gosh.
Yeah, that's right.
Listen, I got like more than.
At least it's only 1. Those of you at home, we got a publicly humiliated child here. I won't say. Can you raise your hand when you have your A and your B, and we'll see if we can get an agreement. You got Toby, what'd you get?
For A, I got 1/2.
We good? So she said 1/2 and a negative 1/2. I'm not going to go through how to get those. It's yesterday's notes. So, really what I have is the 2 out front, right? Maybe factor out a 1/2. You all right with that? And then natural log, absolute value, u minus 1. Now be careful. Then what? Minus natural log, absolute value, u plus 1. Wow. Plus Carl. About done here. You're going to have a good 40 minutes to work. Now, here's what you're going to see. Like if I were to Wolfram alpha this, obviously it's been programmed by a computer programmer to cancel those. It's also been programmed to use properties of natural log. So again, it's not a human, it's a computer, and somebody programmed it. Always factor. Always clean up natural logs. So you wouldn't see that subtraction. What do you think we would see? Division. Yeah, we'd see a u minus 1 and a u plus 1. Plus Carl. However, there's one final step. And this is where last year I used to say this problem wasn't about you. Plug it back in. And I forgot even what it was. What was u? Square root of x plus 1. So we've got the natural log, absolute value, square root of x plus 1 minus 1 over square root of x plus 1 plus 1 plus Carl. Did I say last year that Calc DC was easy?
No.
I said it's fun. And for those of you who need more of a challenge, you're fine. Like some of you are coming in where last year you didn't say that's fun, but you two just said that's kind of fun yesterday. Because you finally get to like think a little more when you're the top ones from last year moving on up. Does that make sense? So you were the ones that tended to be bored last year with me at some times. Am I right, Gabe? So still, I mean, it's not like it's super easy, right, Luce? Right, Cole? I mean, it's not that it's easy, but you're much more focused because you're like, oh, I kind of have to watch this. You are, though, so it's awesome. So, for the rest of the hour. So honestly, those of you who are caught up, those who are publicly humiliated, go watch your notes. Chromebook out, watch notes. Next up, those of you who finished 1 through 10 yesterday, you're going to finish off that worksheet. You can go ahead and submit if you don't have any more homework today. How many of you are done through number 10? There's almost all of you. Awesome. 1 second, Lewis. Spaniard, give me 1 more second. Those of you,
I know. I just got to it.
alright, so those of you who are already done with 1 through 10, you'll finish this in class, and if that's all you want to do and you want to take tonight off or tomorrow, or the rest of the hour even, because you guys, yesterday actually, the A group, like I said, they got to number 8 in like 15 minutes, so I don't anticipate that 11 through 17 taking you particularly long. But tomorrow's is Delta Math, so if you get done, you know, we still have 35, 40 minutes. If you want to start digging into that, you can. Yeah, what's your question, dear?
What time is the Delta Math due tomorrow?
I'll have to check, because I make them on Sundays, so, and I'm making them for AB and BC, so I don't. The question at home was, when is Delta Math due? I'll take a look. I think Sunday night is what I made it. Yep.
Do you have a second page of this worksheet?
Yes. Yep. Okay, I'm going to stop recording now. Yeah, I do have that.